In this video, we will be practicing mainly how to balance chemical equations, but it's also going to force you to practice converting from the words into the actual chemical symbols of an equation or of a chemical. Okay, so we have sulfur, which remember sulfur can never be by itself. There's always 8 of them, so S8. And plus oxygen. Oxygen cannot be by itself. It's diatomic, which means there's always 2 of them. And then over here, sulfur dioxide, we see the prefix. We know that sulfur and oxygen are both non-metals, which means this is a covalent bond. So we're going to use prefixes to write the formula. So we have SO2 on this side. Okay, in our PowerPoint, what you see is that I have you make a chart. We have sulfur and oxygen. They're the only 2 chemicals we have. Okay, remember the rule states that you should do your metals first. So I'll put an M for metals. And then you should go through and try and balance all your non-metals. And then save your hydrogens and oxygens for last because they're typically in multiple spots. So on the left-hand side, we have a total of 8 sulfurs. On the right-hand side, we only have 1. On the left-hand side, we have 2 oxygens. On the right-hand side, we have 2 oxygens. So as of right now, our oxygens are balanced. Okay, our sulfurs are not. If we have 8 sulfurs on the left, we need 8 sulfurs on the right. So if I take a look at this, okay, we need to see, is it possible to multiply my 1 sulfur by 1 number in order to have a total of 8 sulfurs? And yes, it is. If I put a big number 8 here, this is called the coefficient. 8 times this 1 sulfur gives me now a total of 8 sulfurs on the right-hand side. However, that also changes my number of oxygen. 8 times the 2 oxygen here gives me a total of 16 oxygens on the right-hand side. Well, now that's a problem because now my number of oxygens are not balanced. So I come over here to the left-hand side and say, is there some number that I can multiply my 2 oxygens by in order to have a total of 16 oxygens? The answer is yes. I'm going to multiply it by 8. Okay, so 8 times 2 gives me 16. I now have 8 sulfurs on both sides, 16 oxygen on both sides. I'm done. And a lot of online work, quizzes, tests, if I were to ask you for the coefficients of this, here's how we would write it, or pick from a multiple choice. We have 1 S8, 8 O2s, and 8 SO2s. Okay, so they are the coefficients for the chemical compounds. Okay, so going down to a next one, I have zinc, which is Zn, plus sulfuric acid. Remember, sulfuric acid is also hydrogen sulfate. So hydrogen, which is +1, and sulfate, which is SO4 with a -2 charge, so swap and drop. Okay, so that gives me H2 SO4 1. Okay, gives me zinc. Zinc has a +2 charge. Sulfate has a -2 charge. And hydrogen, which is all by itself. So I have zinc +2, sulfate -2, they cancel each other out. Plus hydrogen can never be by itself, it's diatomic, so we got to give it a 2. You should be able to look at this reaction and tell that it is a single displacement reaction. Okay, we have the single metal replacing the hydrogen acting as a metal in the actual compound. That's why hydrogen ends up by itself over here. We're also checking to see that our positive charges are now mixing with our negative charges. Okay, I neglected to say that the first one was a synthesis problem. Okay, so from here we've got a balance. So we have zinc, we have 1 on both sides. We have hydrogen. Hydrogen, we have 2 on the left. Hydrogen, we have 2 on the right. Sulfur, we have 1 on the left, 1 on the right. Oxygen, we have 4 on the left, and we have 4 on the right. You'll notice that we are already balanced. Everything is good. Okay, now, some of you, I've talked about the idea that we can keep our polyatomic ions together if they're the same on both sides. So SO4, sulfate, stays together as sulfate on this side. So what our chart would look like then is 1 zinc on both sides, 2 hydrogens on both sides, and 1 sulfate on both sides. Okay, that seems to make it a little bit easier for some people. Some people hate it, don't ever want to do it, but for a good number of people, being able to see this together as one team actually makes their lives a little bit easier. Okay, let's go ahead and try one or two more. This one here, we have hydrogen, which is diatomic, plus nitrogen, which is diatomic, gives you ammonia, which is nitrogen trihydride. Okay, so we see it's a synthesis problem. Okay, if we make our little chart, hydrogen, nitrogen, I have 2 hydrogens on the left, 3 on the right, 2 nitrogens on the left, and only 1 nitrogen on the right. Okay, so I'm going to fix my nitrogens first. So I can put a big number 2 in front here. 2 times my 1 nitrogen gives me a total of 2 nitrogens. 2 times my 3 hydrogens, though, now gives me 6 hydrogens. So now my number of hydrogens are off. So if I come over here, I look at my equation. Is there some number that I can multiply my 2 hydrogens by to get 6? The answer is yes, 3. So 3 times my 2 hydrogen gives me 6 hydrogen. So 6, 6, 2, 2. Everything's good. Okay, I'm going to skip down, see if I can find something that might have some numbers that are a little bit different. Or at least have another polyatomic ion. Okay, here we go. Let's pop down here. So I have barium chloride. Barium is Ba with a positive 2 charge. Chlorine is Cl with a -1 charge. Sulfuric acid, as we've already said, is hydrogen, which has a positive 1 charge, and sulfate, which has a -2 charge. Over here, we're going to end up with barium, which is +2, sulfate, which is -2, and then hydrochloric acid. Hydrochloric acid is hydrogen, which is +1, and chlorine, which is -1. Okay. So let's see what we got. We have BaCl2 when we swap and drop, plus swap and drop H2SO4 yields barium's +2, sulfates -2. They cancel each other out. So BaSO4 plus hydrogen chloride, which is HCl, because their charges cancel each other out. Okay, so we go and balance it. We have barium, we have 1 on both sides. We have chlorine, we have 2 on the left. We have, only 1 on the right. We have hydrogen, we have 2 on the left and only 1 on the right. Notice our sulfate stays together again. You have SO4 on the left, 1 of them, and SO4 on the right, 1 of them. So here you can see that our hydrogen and our chlorine are not balanced. Okay, so we come over here to the right-hand side. And if I want to have 2 chlorine, I'm going to have to put a big number 2 in front here. 2 times my 1 hydrogen gives me 2 hydrogens. 2 times my 1 chlorine gives me 2 chlorine. You'll see that your bariums are already balanced, your chlorines are now balanced, hydrogens now balanced, sulfates are now balanced. Okay, all right. Some problems are going to be harder than others to balance. You just got to take your time. Hope that helps.